acknowledge some people, and I know that this is what everyone starts paying attention again, so I know I have your attention. It's everyone's favorite slide, and I figure I would bring it, so bear with me. I just wanna thank Jim. I mean, it's been great working with you. You know, like you're a little tough. Okay, you're really tough sometimes. You know, like, Jim can be really tough, but at the same time, like that really formed us as like good scientists. You know, like he makes us always be prepared. He pushes us hard. He expects a lot from us, and he wants us to always be like thinking, like be prepared, like right on our toes. And I'm very excited to keep working with Jim in China for the next year and a half or so. So thanks, Jim. Steve, where are you? There you are. Thank you. You know, Steve was always just checking in on Erica and I. Like he was always making sure that we were doing well. He's always full of good suggestions. He was my second reader for my thesis. You know, thank you, Steve, so much. Tien, there you go. Thank you, Tien. Tien came also into my committee after one of my committee members left. He has been a great contribution to my committee. He had the idea on like how to do the focal adhesion experiments. You know, sometimes it's a little quiet, and then he says something like, "Bang! That's the right answer." It's like, "Oh, thank you." So that's what. Sijun is my chair. Every time I run into Sijun, he asks me how I'm doing. You know, like we always talk about this. Like I can tell that you really care that I graduate eventually, and I am graduating. It'll depend on you guys. So thank you, Sijun. And Michael is like a second boss in the good way. You know, our labs are neighbors, and Michael, I couldn't have done any of the mouse experiments without Michael, but you know, in addition to all the science, I mean, Michael was full of good ideas too. I feel that our labs, the Shao lab and the Sherman labs, are just like one big happy lab that steal each other's pipettes, you know? Some of us steal more pipettes than others. You know, Michael invited us to their lab meetings. He took us out for lunch. You know, like we really feel that we're part of your lab too. So thanks. I of course want to thank the past and current members of the Shao lab. Duke was my mentor when I rotated in the lab. He also was my roommate and a very good friend. He unfortunately couldn't be here today because he's a real doctor and he's like doing patients and stuff. And Junfeng helped me get started with everything. He helped me in every single step of the way until he abandoned me to go to San Francisco. But he, you know, we also became very good friends, and I really appreciate him. Erica is just my partner in crime. I mean, I don't know, like, just life in the lab was just so much better because Erica and I are such good friends. And, you know, it would have been completely different. I don't know if it would have been nearly as much fun or as enjoyable if Erica hadn't been, you know, in the lab with me for the past 5 years in lab. And even before I came to lab, you know. So thanks, Erica, you're awesome. The Sherman lab, as I told you, I mean, we're buddies, you guys. And you know, everyone always thanks Barbara, and it's true. Because I don't think anyone could have like made it through grad school without Barbara. You know, like she's always checking in on us. You know,
I'm sure you would have done fine.
And I was especially lucky because I had 2 people like this. So thank you, Karen, for always being like there, supporting me, always checking in on me. You know, so you guys had Barbara, and Karen. Think about it. And of course, the Department of Biochemistry. I mean, Vicky. I don't know how Vicky puts up with all of us. Oh my God, she's great. My rugby team. There are 2 of my rugby mates over here. You know, being in Boston would have been the same without my rugby team. Jim told you how I break all the time. It's them really that break me. And my family and my friends, my parents, Walter and Monica, and my siblings, Christopher, Constanza, and Joseph. I left home when I was 16, and they've been just so supportive of me all the time. You know, their love and support is really what keeps me here. And last but not least, my girlfriend that is sitting over there. So thanks, Anna. You're kind of amazing. We're moving to China together to be with Jim. So that's kind of crazy. And, and of course, funding comes from the NIH and from the DoD. So thanks, Army, for giving me money. That's it. Thank you, guys.
That's great. Now let's have a question for him. Yes.
Yes.
So, obviously, you're looking down the line to think we can use these as targets for drug design. But that takes a long time. Is there any way you can use them diagnostically ahead of time to see when would be a good time to treat cancers more aggressively so you can take off?
Yeah, so for people in the back, I was told that I needed to repeat the question. So the question is whether P63 could use in diagnosis. And the answer is that it is being used to a great extent to diagnose squamous cell carcinomas already. To predict prognosis is a little bit harder because on the one hand, yes, it is good when there's plenty of P63 because then you think that the cancer is not going to be metastatic. But then there's a subset of breast cancers, which are basal breast carcinoma, which overexpress P63, right? And those cancers have somehow circumvented the inhibition of P63 on metastasis and are actually very aggressive. So that is the exception that always comes up when people try to use P63 as a prognosis indicator. For other cancers, it more or less works. That if you do have P63, then it's better prognosis. But you have to be very wary, especially in breast cancer, because of those, because of basal breast carcinoma. Barbara.
Great. So you mentioned that cleft palate is associated with P63
Yes.
mutations. And is there anything known about susceptibility of these patients to cancer, well, to metastatic cancer?
The literature specifically doesn't say that there is any sort of correlation. People have tried to find correlations, but they haven't really found real correlation. So sorry, so the question was whether patients with autosomal heterozygous mutations on P63 could be susceptible to metastatic cancer. And the answer is that there's no evidence to suggest that. Maybe because it is an autosomal mutation, it's affecting maybe just like parts of the body. But yeah, there are no reports to suggest that is the case. Oh.
Yeah, in addition to the matrix metalloproteases that are allowing the movement through the matrix, there are things like beta-proteasomes and things like this in addition to focal adhesions. What's known about the remodeling of the cytoskeleton and under these circumstances, if anything?
The remodeling of the cytoskeleton by
That
P63?
allows the migration and motility.
Well, P63, the delta and isoforms have been shown to also upregulate some forms of laminin and some forms of extracellular matrix, some proteins that are part of the extracellular matrix, and therefore enhance cell adhesion. Actually, P63 is a master regulator of cell adhesive molecules, including not only integrins, but also components of the cellular matrix. So in general, they promote cells to like stay adhered. They promote the extracellular matrix to remain stable. So does that answer the question?
No.
I feel like, what is your question, Paul? Where is
The
the Paul?
question is, why do they move? In addition, I mean, they need a couple things to move. They need to get through the extracellular matrix, so they make metalloproteases, and that chews up the extracellular matrix. They also need motility. They need fingers and other things that move them through into, say,